stop by afterwards and just talk to me about your parking story. Okay? Here we go. Not sure why that's there. Okay. All right, you said we're on slide 10, so here I go. Who's moving that?
It's you, you're playing the video. At the bottom.
Yeah, I know, but
That's,
I'm playing a video?
yeah,
Why?
You're playing Friday's lesson.
I am, huh? So then go here. Okay.
I want to look at this stuff.
Oh, you're right. Get out of here. I can't get this thing off. Okay, let's go like this. Let's go like this. Okay, here we go. That's what I want. That's the one I want to be on right there. Now, is this going to work? It should be recording right now. Let's hope it's recording. Okay, here we go. Your job in this slide is to give me the center. Give me the center, the foci, and the vertices of the ellipse, and then sketch it. There's a lot to this, just so you know, so get ready to write. All right. Now, the second you look at this equation, can you tell me why it's an ellipse? Just look at it. Okay, good. You got an x squared. You got a y squared. Right there, that tells me this is an ellipse. Okay? So you have an ellipse because you have x squared, y squared. All right. Your job is to get this to be one of our equations that we've talked about. And then here's the first thing I would do is just kind of write down what you want this equation to look like. You know, the a squared and the b squared, do you remember that a squared has to go below which one? Wherever, okay, think of the major axis. If the major axis is horizontal, it's got to go under x. If the major axis is vertical, it's got to go under y. Now, let me just draw you a quick sketch of this again. Remember last week we talked about the major axis. If this is the major axis, what falls on it? Those are called what?
Vertices.
Vertice. What's this called?
Center.
Center. And this was called what?
Foci.
These are foci. Right? Everybody remember this? Now, if you've got a major axis, horizontal major, then your a squared has to go underneath x. But if you had this ellipse right here, now you got a major going up and down, now it goes under y. The a squared would have to go under the y. Okay? Now, a couple other things before I move on, and that is, do you remember this? The distance from here to here is how far? We called it a distance, we called it what letter?
C.
C. Okay, do you remember this distance from center up the minor?
B.
That's B. Do you remember this one from, sorry, let's go this way. Center to the vertice. Wasn't that A? Okay, now, I created a triangle for you. I called it from foci up to the top of the ellipse. This distance right here, guys, turned out to be what distance? Remember, from foci to the top was exactly the same as center to the vertice. This is A. And with that triangle, you have a right triangle. Okay? You see that C right there? Can you not look? That was supposed to be the center. All right. With that triangle, you're supposed to be thinking every ellipse can be the ABCs can be found by a squared equals b squared plus c squared. Does that make sense? Does that ring a bell? That was Friday. Okay? All right, so I'm going to get rid of that. Hopefully you remember me talking about that on Friday, so it doesn't surprise you. Okay, here's your job. Your job is to get that equation to look like this equation. How do we do it? How do I get that to look like this?
Separate the x's and y's.
Separate the x's and the y's. And then you're eventually going to have to get x minus h squared. This is a binomial squared. Where do they come from? Factoring what?
I don't know what to call
You don't know what it's called? You know, Darren? Okay, watch this. X squared plus 9 plus 6x. This factors into what?
X plus 3.
X plus 3 times x plus 3. This right here is called a perfect trinomial. Your job is to get this to be a perfect trinomial, factor it into this. You get the y's to be a perfect trinomial, factor it into this. So the idea is what Corey said. Separate the x's and the y's, and then you never said this, Corey, complete the square. We're going to complete the square is what we're going to do. All right, here we go. I'll box this in. I'm going to separate x's from y's, 9x squared plus 36x plus blank. Leave a blank because you're going to complete the square. Then put the y's in, plus 4y squared minus 8y plus blank. Move the constant 4 to the other side. So it becomes negative 4. So you just want the x squared, the x squared term, then the x, the y squared term, then the y. Move the constant over. Do you remember how to complete the square?
Take the b value, put it over 2, and square that.
Take the b value, okay. Take the b value, put it over 2, cut it in half, then square it. She's right, except for one thing. Don't start completing the square until what?
Don't we have to factor out if there's something?
Yeah, that's exactly what I was going to say. Don't start until you get x squared all by itself. Don't start until you get y squared all by itself. So Frankie, what do you want me to do?
Take out a 9.
Take out a 9. What's left?
X plus 4.
4x
Or x squared plus 4x, yeah.
plus blank. We'll complete the square in just a second. Now take out what?
4
4. Y squared
minus 2.
minus 2y plus blank equals negative 4. Before you complete the square, get x squared by itself or y squared by itself. Okay, now complete the square. Take the b value, 4, cut it in half, square it, you get 4. Put a 4 here. So you're adding 4 to the left side. Do you go add 4 to the right side? What?
You're adding 36.
You're not adding 4. I said it. I said you add 4 here, but you're not adding 4. It's 9 times 4, which is 36. So you're going to add 36 to this side. Okay? Complete the square on the next one. Half of negative 2. Square it. What'd you get, 1? Add 1, but you don't add 1 to the other side. You add 4. The 4 and the minus 4 are now gone. So now you get, I'm coming down a little further now. You get 9 times x plus 2 squared. You guys understand where I'm getting that from? I'm factoring this trinomial. X plus 2 times x plus 2 is this up here. 2 times 2 is 4, and 2 plus 2 is 4. Plus 4 times, factor that one. Somebody, factor it. y minus 1 squared. Not sure what just happened there. Hang on. Y minus 1 squared. All right. Does this equation look like what I want right here? Not quite. You see that 1 over there? Get the far right side to be 1. Just do what?
Divide by 36.
Divide by 36. Now you get your 1. Divide by 36. And you'll notice 936, 436 reduces to what? X plus 2 squared over y minus 1 squared over. Okay, this one is 4. This one is 9. There. I just took that equation that was pretty long and wrote it so that it's in standard form, which means I can pull out the center right now. What's the center?
Negative 2, 1.
Negative 2, 1. I agree. Good? All right. Do me a favor, somebody. Just tell me the a value. Look at that. Look at the equation. The a value is 3. Yep. The b value is 2. Okay. Let's make a quick sketch of this. You said center, negative 2, 1. Right about there. My question is, which way is the major axis? Up, down, right, left?
Down.
Up, down, because the a value is under y. It's a major axis going up, down, vertical. So from here, what does the a mean? A means go from the center where?
Up 3.
Up 3. You're at 1. So 2. You'll be at 4, won't you? Right about there. And then you go down 3. Right about here. Isn't this the vertex? Vertex center. So what are the vertices in this one? Vertices are? Negative 2, 4, negative 2, negative 2. Yeah, negative 2. You're right. There they are. Center, vertices. What else do they want to know? Oh, wait. Sorry. I know my b value. My b value is 2. Where do I go for 2 on that? Start at the center. Go where? Go on the minor axis. How far? 2 to the right. How far? 2 to the left. Right there. You don't have to label those. Don't label them as vertices. Just know that's the quick sketch you're going to make, right? There. That's my ellipse. Major axis is vertical. Although they do want the foci, don't they? How do you get the foci? It's from the center where? Say something. Where do I go? Left, right, up, down?
Up and down.
Up, down. How far? C. You gotta go C. What's C though? I know B and I know A, but I don't know C. So to go find C, you're gonna have to use your Pythagorean relationship. A squared equals B squared plus C squared. Where A squared is 9. B squared is 4. And just solve it. C squared equals 5, or C equals square root of 5, right? Okay, so where am I going to go to get my foci? How far up? How far down? How far is the square root of 5? About.
A little over 2.
Little over 2. So 1, 2. Okay, I'm about right here. This is the foci, and a little further down than 2, about here. Foci. I want the ordered pair. The ordered pair is basically the center plus C and the center minus C. Okay, but here's the deal. Which one would you add it to? Here's your center. Would you add c to the x, or would you add c to the y? Yeah, it's the y. Up, down. Okay, so you're going to say my foci will be -2, comma. Now take the y value, 1, on the center, and go up square root of 5. Now that's a number, by the way, and that's like 3 point something, 3.2, 3.3. That's the upper foci. The lower foci would be 1 minus. So can I just do this instead of writing the whole thing over? Does everybody understand? I'm giving you two ordered pairs. -2 comma 1 plus square root of 5, -2 comma 1 minus square root of 5. Okay, I've given you all the information. I sketched it for you. There it is. Whew. That took a lot of work. You had to complete the square. You had to look at the equation, get your A, B. You had to sketch it, find the vertices, find the foci. That's a big problem. That's why this test takes a long time, by the way. Okay. Next would be, eccentricity. Eccentricity is just a formula. E for eccentricity equals c divided by a. What does it measure? The roundness of an ellipse. How round it is. So what I mean by that is, you might get an ellipse that looks like this. Okay, versus this. Which one's more elliptical? This one is? This one's more elliptical? To me, the more elliptical would be like if you stretched out a circle farther and farther. This one's more, I think this one's more elliptical and this one's more circular. Like this one almost looks like a circle, doesn't it? But it isn't. Well, you don't know, I guess, until I tell you, but this would have to be versus this one. One of these has to be major. One of them has to be what? Minor. If this is longer than this, you do have an ellipse. It's just not it's not really elliptical. It's more circular versus this one. Now, here's what I want to do. All it is, oops. Okay, what's going on? Okay. They're going to make me start over. All it is this. Okay. If I put this as the center and I say this is the vertex, what's the distance from here to here? A, B, C. That's it. Okay. What if I put the foci right here? What's this distance right here?
C.
C. You guys know this is more circular than elliptical. So you know that distance is really small and that distance is much bigger. Give me a number that would be really small. Something? Like what? 0.1. He's going really small. Give me something like an integer. 1. Okay, so Corey says the C value, C over A, he says the C value is 1. What's the A value going to be? Well, if this is 1, this looks like 4. Okay. All right. So the eccentricity of this ellipse is 1/4. Okay. That doesn't tell you much yet, but let's do the other one. Let's pretend we're looking at this one. Center's right there. Let's put the foci way over here. Okay. And let's put the vertex right there. Now you tell me, in this case, the eccentricity of this one, C over A, give me a number that would match this picture. Give me a bigger number for this. But by the way, this is C. Give me a number.
7.
7. You're telling me this is 7, but doesn't this distance, which is A, doesn't it look very close to 7? It's got to be a little bigger, like what?
8.
8. So what's the eccentricity of this one? 8 over 7 over, yeah, 7 over 8, my fault. Oh no, I got to erase. I knew it wouldn't work. It's not working, sorry. Let's go over here. 7 over 8, which is very close to what number? 1. So when the number gets closer and closer to 1, the ellipse gets more elliptical. When the number gets closer and closer to what? 0. If this number gets closer and closer to 0, you have a more circular ellipse. It doesn't look like an ellipse anymore. So, if anything, I think you guys should write this. If E ranges from 1 down to 0, the closer you are to 0, the more what? The more circular your ellipse will look. It won't look like an ellipse, it will start to look like a circle. As the eccentricity gets closer and closer to 1, then it looks more what? More elliptical? Okay? And that's all that eccentricity measures. How elliptical is it? Closer to 1, very elliptical. Closer to 0, looks more like a circle. Okay? One more thing about your equation for ellipses. What would cause the equation up here above to be the equation of a circle? Marion, do you know?
If A and B were the same
If A and B are the same,
number.
so you're saying if the A squared and the B squared, or just A and B? Doesn't really matter, I guess, does it? No. If the A squared and the B squared happen to be the same, then you have a circle. Everybody agree? So if I had x squared over 16 plus y squared over 16, which one's the major axis? Can you tell? No, they're exactly the same. So the major axis, let's just say, is 16. The minor axis is 16. Well, that would tell me the A value here would be 4, and the B value would be what? 4. Well, if I graphed it, center at 0, 0, 4 here, 4 there, 4 up, 4 down, you have a what? You have a circle. If the A squared and the B squared are the same, you have a circle. Once they change on you, then one axis gets bigger, which brings in the ellipse. Okay, last slide. Here it is. This is the story problem that goes with ellipses, and this is something on the quiz Wednesday that you're going to have to do. All right. A bridge is built in the shape of a semi-elliptical arch. I hope you see it. It almost looks like a parabola, doesn't it? But because they said semi-elliptical, you have to assume that it goes under the ground, curls around, comes back up. So it is an ellipse. So your job is to take it and write an equation for this. Okay, now here's my question to you. Where are you going to put the 0, 0? You know how you have to put the xy axis down somewhere? Where are you going to put 0, 0? Yeah, wouldn't it make sense to put it at the center? Right about there. 0, comma, 0. This would be the y-axis coming straight down. Just knowing 0, 0 is right there, you should be able to read this problem and stick numbers in the right spot. It says the bridge has a span of 160 feet and a height of 40. Just those two comments they made, 160 feet wide, 40 feet high. What can you tell me about this point right here? 0 what? 0, 40? That point is 0, 40. What about this point right there? Right there. Or here, I don't care.
160.
Say again. 160, 0.
That would be 80, I think. Maybe.
Well, I think it's, the bridge has a span of 160 feet. It spans 160, so from the center this way would be 80 and 80. So this would be 80, 0, and what?
Negative 80.
Negative 80, 0, okay. So there it is. What is the height of the arch at a distance 40 feet from the center? From the center, if I move 40 feet, I'd call that 40 about right there. What's the height of the arch? Right here. What is that? That ordered pair would be what? I bet you know X or Y on that pair. X is 40. Y, question mark, don't know it. The only way you're going to get that point, 40 comma something, is to write an equation for this and then go solve it. Now, looking at that ellipse, since you know the center is 0, 0, you should know right away what's on top. No, if it's 0, 0, it's got to be what? X squared, Y squared. If you have a center at 0, 0, there's no shifting right, left, up, down. That center is at 0, 0, so it's just X squared, Y squared. Underneath is where you have to get this right. Which one's A?
X.
Okay, you want the A here? How come?
It's 40 up, but it's 80 this way.
Okay, I guess what I'm thinking is the major axis is how far from here to here? How far? It's actually 160, the major. What's the minor this way? 80. So guys, the major one is this way, right? It's horizontal. You have to think my A value is from here to here. How far? 80. Your 80 should go right there. 80 squared. Okay, this is where the A squared should have went, under the X squared. All right, what goes under the Y squared? The B value. The B value here is, it's hard to see when I do this. B is what? All the way up, 40. So this would be a 40 squared. If I simplify this equation, it's X squared over 6,400. Y squared over 1600 equals 1. Okay, that is the equation. That will get you any point on the ellipse. Any point. So what point do you want? 40 over from the center, up how high? So really what you want is this. You want to fill in the blank. So you're going to put 40 in for X, and then you're going to solve. I'll just turn you loose now. You get that answer. Let me see what you got when I walk by you. Okay, continue to work. Let me see it. I do want to make sure I can solve that equation. Just get that. Hang on, let me see what you do. Okay, good. Then you went. Refresh. Perfect. Then you did what?
Multiply 4 by 1600. Like multiply each side by 1600, so it's just Y squared.
Oh, hang on. Watch this. See if it's multiply both sides.
Oh, it'd be at the top.
Yeah, see,
Okay.
200 times 3 is a 1 and another 4. Good.
No, I had math in.
Math there, okay. You get it? Look like you're scribbling over here. It's good looking scribbling. That's it. You got it. One person has it. Anybody else? Oh, I don't know. Oh, I see what you did. Okay. Yeah, I'm sure that's right. Yeah. Most people just did this though. 34 feet or something like that. Yep. You guys get it? 34.64 feet. Yep. You get it? No?
I'm kind of stuck.
Oh, okay. Well, I'm gonna do it in about 1 minute. I think I have 6 people right now that have it. Yep, that's it. Yep, that's it. You get it? Okay. You got it. Okay, here we go. 40 squared, 1600 over 6400. Okay. You know what, guys? You can take your calculator, hit that, reduce it. It will reduce it for you. But look, 100 goes in there 16 times, 64 times. 16 over 64, that's just 1/4. Right? Okay, so 1600 over 6400 reduces to 1/4. Solve the equation. What are you going to do? Yeah, get the y squared all by itself. Move that over, minus 1/4. You get 3/4 equals y squared over 1600. What'd you do from here though?
Take it to 1600 on both sides.
You multiply by 6400?
Well, I did it totally different than what you did.
Okay, so you would multiply by 6400. Does anybody else do something different? What do you do, Ivy? No, I don't mean did you do something different. I meant would you solve that differently? Nobody from, when we did trig, didn't we cross multiply proportions?
Well, that's what I did, but I used different proportions.
Okay. Well, Corey, what you said, multiply by 1600 works. Out with the 1600s. This is just 1600 over 1 times this. If you took your calculator, you do get 1200. You do. Okay. Square root, you get your 34.64 feet. Okay, that is the height of the bridge. So if you look at the picture, guys, doesn't the bridge, I mean, as you move over from the center, it doesn't drop very much, does it? But you know the answer should be in the 30s, I think. I mean, if you would have got an answer, like period 4, you know what the answer was? The first 2 people I checked? 80 and 80. Does 80 make sense to you? What's the highest it could be? 40. They got 80, and they thought that was right. And by the way, those 2 students, they're A students. They get A's. Do you want to know what they did?
I kind of see how that happens.
Do you? Well, I got to show you something. You know what they did? They went like this. Where is it? Oh, right here. You see how it says 1600 over 6400, and then plus y squared over 1600 equals 1? You know what they did? Anybody?
Crossed out 1600.
Yep, they did this. They went like this. Boom, boom. That's what they did. Can you cross out 1600 with 1600 when there's a plus sign? No, only when there's a times sign, multiplication. They made that mistake, and they knew right away when I said you can't do that. Oh, yeah, got it. But they had a number, 80. Their answer was 80. It made no sense, but they thought it was right. Which I think is kind of funny, because I think you need to make sense of this. It should be below 40. How far? 35, 30? You should get in that ballpark. All right, that's all I have. if you have questions from Friday, you should say them now.
Oh.
Jeez, 2 minutes. Oh. That doesn't leave you much time to ask. Matter of fact, I don't think we can get much done there.